Hello, this is Excellential Chemistry, and this is a qualitative analysis of this year's WASSCE, that is 2026 WASSCE. And the sample, we have a mixture of starch and lead 2-triazocarbonate, for that is lead carbonate. That is a mixture, and you are asked to mix it ratio 1:1. So I've already mixed it here. Now, the first thing we do is to check the solubility of the sample. It's very obvious to be insoluble in water. For want of time, I don't want to bother with that aspect. So the next thing, we get a sample of the mixture, put it inside the boiling tube. It's a boiling tube. Put inside the boiling tube. I'm using 2 spatula full so as to get enough result observation. So this is the mixture. And what are we going to do on this? We add dilute trioxynitrate 5 acid. Dilute trioxynitrate 5 acid. Now, when we add dilute trioxynitrate 5 acid, there will be effervescence of a colorless and odorless gas. Of course, the gas will be carbon dioxide from a carbonate. So we are going to prepare lime water. I've already prepared lime water. Lime water is calcium hydroxide solution. So I've already dissolved it in water and filtered. So this is lime water I have already prepared. Now, in exam situation, nobody tells you when to use lime water. You should know that any gas that comes out, you have to test it. And you state the gas and where the source of the gas. So I've already prepared lime water. Now, I have to prepare it before adding the nitric acid to the mixture. Now, I'm going to add triazonitrate 5 acid here. And this is my gas delivery tube. I've got everything ready before adding the nitric acid. This is the triazonitrate 5 acid. I'm ready to add it. So, adding the dilute nitric acid to this, you see effervescence. As the effervescence occurs, I pass the gas immediately through lime water. You see it? You see the lime water is changing, turning milky. You can see it here. It's becoming cloudy. Lime water becomes cloudy. That is, turns milky. What does that show us? It shows us that the gas is carbon dioxide from triazocarbonate 4 or hydrogen triazocarbonate 4. Now, if you had earlier dissolved in water and filtered, you say that gas is carbon dioxide from triazocarbonate 4. But if you've not dissolved it in water prior, you will say that gas is carbon dioxide from triazocarbonate 4 or hydrogen triazocarbonate 4. So this would continue, showing that there is a lot of carbonate inside here. Now, I want to add more acid just to make sure that all the carbonates are gone. All the carbonate is gone. Okay, so I will just allow some seconds for the effervescence to cease. Then I will come back with filter. So the next is to filter. So I prepare my filter paper. This is my filter paper. I prepare my filter paper. I have my funnel already, like a cone. I insert it here. Then I filter. I'm going to filter this mixture, to which I've already added nitric acid. You know, the starch is still there. And now, what you should actually have there is now lead 2-triazonitrate 5. That should be the filtrate. So you still have the lead now is in the filtrate. And the residue remains starch. Starch is the residue. So I filter. Going to allow it some minutes to filter very well. Remember, if you are here, you've not subscribed, can you just hit the subscribe button while we're waiting for this to filter? It will take just some minutes. Maybe I'm just going to pause and come back while you subscribe. and like the video also. Thank you. So we have kept the residue, although it's still filtering, but this is part of the filtrate. We're going to use it multiple times. So what we're going to do on the filtrate, we use, because this filtrate contains lead 2 ion, we use sodium hydroxide aqueous, dilute sodium hydroxide. We add it in drops. Can you see white precipitate forming in drops? It forms and disappears. Now it has persisted. So in drops, we have white precipitate. It still remains in drops. Okay, let me add the next phase now. What do you notice? It has disappeared in excess, right? Dissolved in excess. So the precipitate is looking chalky or a bit cloudy. That shows that we are suspecting the precipitate to be either calcium ion or lead 2 ion. Okay, so we write calcium ion or lead 2 ion. Okay, so we're already suspecting calcium ion or lead 2 ion. How do we distinguish between them? We use this. This is aqueous ammonia. We use aqueous ammonia in drops and in excess. If it's calcium ion, we will not observe anything. But ammonium ion, we're going to observe some things. Okay, let's see. With it's lead 2 ion rather, lead 2 ion. Can you see the white PPT again? With ammonium ion, you see white precipitate. But this time around, it's not dissolving in excess. Okay, it is not dissolving in excess. Still white chalky precipitate. You see, it's not dissolving in excess, which means that we have confirmed lead 2 ion. So far, remember when we saw the effervescence of a colorless and odorless gas, the gas turned line water milky. We say that the gas is carbon 4 oxide from triisocarbonate 4. If we are using solid sample, we say triisocarbonate 4 or hydrogen triisocarbonate 4. But if we're using the one we've already filtered after dissolving in water, we just say triisocarbonate 4. So we have identified the cation. We have also identified an anion. The anion is a triisocarbonate 4. The cation is lead 2 ion. It remains to work with the residue. The residue is still here. Here is the residue. Is here. We're going to confirm iodine from it. We're going to confirm starch from it, please. We're using iodine solution. So I'm going to use ethanol to dissolve iodine. So this is a clean boiling tube. I'm transferring the starch into it. Starch into the boiling tube. Or I even have the starch on the filter paper, so I can even just drop iodine there. This is iodine solution. Dropping it in. You can see it's turning blue black. Although now it's also turning a bit purple or what. It turns blue black and then changes color to purple. So I use the ethanol to make my iodine solution. If you use potassium iodide, it will give you more blue black. Okay, so this blue black coloration shows that starch is present. So that is it. Thank you very much. Stay tuned and subscribe to this channel. I'm going to also do another video for volumetric analysis. Remember, when you get into the hall, try to read the question very well. But now we've given you a hint on what to expect. Best of luck in your examinations. These excellential chemicals. Excellential chemistry, please.